Okay, so let's first fix a couple of bugs here. So if I open the app, you can see that the timer starts right away before even I press start, and the button is set to stop. So we don't want that. And if we take a look here at the view model, the problem is that we initialize the timer to false, which means that in the activity, immediately when we open the screen, we will get this observe will get called, which means, and with is running equal to false, which means we will start the timer and set the text to stop. We don't want that. So the first thing is, let's just, because by default in the activity, the button is set to start text, right? So what we want to do is we don't need any default value. We want the live data to not emit any value at the start of the screen. So if we do that, let's run this and see if that fixes the problem. Okay, so if we do that, the timer is at 0, it doesn't start, the button is still at start, so that works correctly. Now, if I press start here, you can see the button stays at start. Then when I press again, then it starts counting. So there is a problem there. So let's try to fix that one. Okay, so why is when we press the start button, it doesn't start the first time? So if you look here, when we want to toggle the timer and we find that it's true, the value was true, we stop the timer, which means we set the timer to false. So we emit false. And the intent here is to make the timer stop. But the problem here is if it's false, we actually start the timer. So that's wrong. So what we want here is if it's false, we want to stop the timer, right? If the timer is not running, that means the view model told us to stop the timer. And if it's running, that means the view model told us to start the timer. And when the timer is started, what we want to get displayed is stop. For the next possible action is stop. But if the timer is stopped, the next possible action is to start it. So that's why we need to have start here. So maybe we should rename this to make it more obvious. So let's see what could be. Let's say current run state or something, current timer running. Is timer running or something like that, maybe. Then we want to start it, and then otherwise we should stop it, right? So let's check if this works. Okay, so we have the timer starting at 0, that's correct. If we start it, the button switches to stop immediately, that's what we want. And if we stop it, it stays at 10, good, and then the button switches to start. If we do it again, cool. Stop, good. So another bug or problem we have here is that, so if I start the timer here, you can see it started from 10. And if I stop it and just wait a couple of seconds and start it again, you can see it started from 19, not from 14 where we stopped it. So what is happening is that the chronometer keeps running even when we click stop. It's just that it stops updating the timer or the chronometer text here. So we need to fix that. So the way we need to do that is using set-based method that sets, basically what we are going to do is do it ourselves, like keep track of the time that has elapsed and make the timer, instead of starting from, basically when we stop at 14, we want to count the difference between 14 and like 21 when we start, and then subtract it ourselves so we can start at 14 seconds, right? So the way to do that here is that we are going to go to our view model, main view model here. And what we are going to do is keep track here of the base time here of, first actually, let me just show you what I mean here is that we wanna, when you start the timer, we wanna keep track of some value. Basically that value is system clock that elapsed time, like the current elapsed time, elapsed real time, right? this is just the milliseconds since boot, including time spent in sleep, right? So the since boot of the app, of course. And so here what I'm going to do is first I'm going to have something here so that the activity, basically what's the thing is, if I go to main activity here, it's the timer. Actually, let's rename this to chronometer just to make it more accurate. So chronometer. So continue. Let's rename it again. Chronometer. Okay, cool. Now if we go here, we have set base method. And this base here, this is the base time that the timer starts from. So this is what we want to set. But I want to keep track of it in the view model, because remember the UI data should be in the view model. So we are going to say here timer base, which is going to be immutable live data of long. And we are going to initialize it to an empty one. Now when we start here, we want the timer base value to be set to the elapsed time so far, but we want another variable here that keeps track of the difference from the moment we started the timer, so that we can subtract it from whatever the chronometer had stored, right? And so here we want to have a long value equal to 0, and we want to subtract it here. So stop diff. And then when we stop the timer, we want to keep track of that difference here. So that difference would be the current elapsed time minus the base, the one that we initially put during the start time. Basically, this would say that, let's say when we are at 14 seconds, this stop diff would be that 14 seconds. So we want to say timer base dot value, and because this is nullable, we want to start from 0 if it's null, right? And so actually, let's see, why is there an error? This should be good. Elapsed time is long. One thing here is this should be long. Okay. No, long like this. Oh, it's a val. It should be a variable here. Cool. And then we want to expose this to the activity. So let's say timer base here. And this would be a live data. We don't want it mutable for the activity. And so this is a long and timer base. And then in the main activity, you want to observe this and then do this, set the base of the chronometer. So we want to say view model, timer base, and then we want to observe, and then this here, and then observer. And at this point, we want to set the base of the chronometer to be whatever value we have. So this is base. That's what we'll be setting here. Okay, that's pretty much it. So in the view model, we kept track of the stop difference here. When we stop, like how much time had the chronometer logged so far. So we keep track of that, and then we need to, when we start the timer, it starts from current time. We want to have 14 seconds elapsed, right? So that's what we are doing here. So let's try it again. Okay, so let's start the timer. Okay, so now we stop at 4. Let's let a couple of seconds pass by, and start again. Okay, so we can see it starts from 4. Now if we stop at 8, Just give it a couple of seconds and start again. You can see it picked up from 8, 9, 10. So yeah, this works now. So yeah, what we used here is just compute it ourselves and keep track of it ourselves in the view model instead of letting the chronometer handle it, because the chronometer doesn't stop the real time when we click when we call stop. It just stops updating the text. Yeah, so that okay, so now the next step for us is to add a reset button here. So to do that, let's go to the activity here and take this and add a reset button here. And just call it maybe reset timer. And we need to change the text here to reset. And it needs to be below the toggle button. So just call that. And then in the activity, we want to, when it's clicked, we want to do something, but we want the view model to take care of it, right? Because that's where we have the data for the chronometer. So we will have a view model here, and we want to reset timer, right? So let's just create a function here, and so what do we want to do? So when you reset, we want the timer to stop running, right? So to do that, we are going to say value is equal to false. And then this will be, we'll call the callback here in the main activity. This one here, so that the chronometer stops and we change the text back to start. And we want the value on the timer to be 0 since we are resetting, right? So that would mean the timer base should be, the value should be equal to the current elapsed real time, so that it gets set to 0. And then we also want the stop diff here to be 0, right? Because we don't want to keep track anymore of the time that has passed, right? So to do that, we are going to say stop diff equal to 0 here. And that's pretty much it. So let's run this. Okay, so let's start the chronometer. Now let's click reset. So you can see the timer is set back to 0 and it stopped. So that worked. Next step is to add unit tests for our view model here. And so to do that, we need a library that provides us some tools for unit testing. And so we are going to add that one in build Gradle file. So if we go here under test, we could add the library, which is Android Architecture Core Testing library. And then we will need, let's just organize this a little bit, put the implementations together, tests together, and these are for the UI tests, so it makes sense to put them together. Okay, so now let's sync and let's go to the view model. What we want to do here is we want to create a test, right? So let's go to the project view and let's go to the text section, remove this dummy one that Android Studio created, and create our own test. So let's call that main view model. Or we can actually, there is also another way we can do this, which is just go here, create test, and we want a unit test, not a UI test. And so we'll put it there. Let's just remove this groovy thing here. The only problem is that it created it in Java, so we don't want that. So let's just remove it then, create in colon. So we need main view model test. Okay, and our test class will need to So test class, when we will need to say that we want it to run with unit 4. So to do that, we're just going to say specify the runner here, which is a unit 4 class, right? Support it. And now we want to do a couple of things. We want to do the setup step, right? So we can define the model object. So let's just first define it here. So that would be main view model like this, and we want to initialize it here in the test. And that's pretty much it. So what should we test here? If we look at the main view model, we have this toggle method, which is public. So we want to test the public methods. So let's just put them here together. We have these private methods. We don't want to test them, but we want to test these methods, toggle and reset. So toggle, there are two variations. We want to make sure that if the timer was running and we say toggle, we want to stop it, stop the timer. And when the timer is stopped, it's not running, we want to, and we call toggle, we want the timer to start, right? So let's cover that up. But first, let's just run this and see if it works. So you can see we have initialization error here. Invalid test class. So the problem here is that there is just no test method. So let's first define our first test method for the function toggle timer that we mentioned here. So the first thing we want to do, we want to test is that when the timer is running, basically toggling a running timer stops the timer. And so let's define that function. In colon we can make we can put a phrase, like a valid phrase, as a function name, and so as a test method name. So we can say toggle running timer stops timer, right? So this is our first test function. And then let's run this just to make sure that now it works, because this is, so you can see the previous error was just because the test didn't have any methods. So now it passes. So let's start running this, but we want also an equivalent test here. We want that toggle running stop it timer, right? Should start timer, just the reverse. So here to test this, we want first, so the timer starts out as not running, right? And then we want to start it. So start timer or chronometer, and then that would be main view model toggle. We want to call toggle, right? And then we want to assert that the timer stopped running. And so to do that, we can just check in the main view model. Remember, we have timer state, which gives us the state of the timer, whether it's running or not. It's a boolean, it gives a boolean value. So we can just get that value and make sure that it's true. If it's true, that means the test passed. That means the timer is, sorry, we wanted to stop the timer. So we want this to be false, right? But here, when we start the timer, it's running. So we want to run toggle again so that it stops it. And now, we want this to pass, because now, so we start the timer and then we want to stop it. So we want to make sure here assert that timer has stopped, right? So let's run this. So this one is good. Toggle stop timer. This is the second one. This one has a problem, and you can see here this runtime main looper is not marked here. This is because just we need to add this instant task role, because we are using live data in the model. We want to use this to make this error go away. And so if we run this again, we still have a problem, right? So elapsed real time from system clock could not be marked. So if we go back to the model, the problem is we can't mark this, right? And it's the static call, and these are usually bad in a view model. So we want a way to be able to test, and so we can just move this to be passed by the activity instead, and have the view model just use that. So let's make this a parameter. Let's call it elapsed time here. And let's do the same thing for these other ones. So the toggle here, we'll need to pass these to the methods below. So this is elapsed time. Same thing here. And then that means that these, it needs to be a parameter of toggle timer so that the activity passes it. And now it's the job of the activity here to pass the elapsed time to both toggle and reset. And now we no longer have any reference to system clock in the view model, which is great. So now we can go back to our tests and instead pass the elapsed time ourselves. So this would be 0. Let's say here it's 4. We stop it after 4 seconds. So now it should work. Okay, so now great. Our test function here works. Now let's write the test for this one. So this is just toggling a stop timer should start the timer. So the timer initially is stopped, right? So we can just start the timer and then assert that the timer is running, right? So here, assert that timer is running, has started, which means basically that it's running. And so to do that, we want to assert that this is true instead. So if we run this, so now we can see that both tests pass it. So great. Next step is to test reset timer, right? So we're gonna test that. That when we reset the timer, it does what it's supposed to do. So let's write this test here. So let's say test reset timer stops the timer, right? It should stop the timer and it should set the values to 0, right? So what should we do here? So first we want to start the timer, right? So we toggle it, say starting at 12, and then we want to reset the timer, let's say after a couple of seconds, so let's say at 25. And then we want to make sure that assert it stops the timer, right? So that would mean we want to assert that the timer is now running. So we want to assert that timer running value is false. And so to do that, we want to get the main view model here, get the timer state, and get the value. And we want to make sure that the value is false. The next thing we want to do here is we want if we go back to the main view model, we can see that we also want the base value to be set back to elapsed time, and we want, so pretty much we want this to happen. This is internal to the main view model, so we don't want to check it, but we do want to check that this happened. And since the timer base here is exposed via timer base function, public function here, we could use that. So what we can do here is basically assert that some value is equal to main view model timer base value. Now what should it be equal to, right? It should be equal to this time where we reset it. That should be the new base, right? So let's just give this a value, elapsed time, and this should be equal to that. Because when we run the timer again, we want it to start we wanted to start from that. So let's just run this. Okay, so that works as well. So our next task here is we want to style our stopwatch similar to Google's clock here. So we want the buttons to be aligned horizontally, right? So, and we want to give it a black background. So let's get to this. So the first thing is make the buttons aligned horizontally. So to do that, we want to go to the activity here, and we want, so we have the reset toggle. So maybe let's add a lap button. We may not do the logic for it, but let's just add it here. And then we need lap, create a value here. It needs to be, so toggle timer needs to have to be to the bottom of the chronometer, this button too, but we want to align it to the base. We want to have the toggle button base aligned with the reset timer so that they can be horizontally aligned like this without needing an extra layout. We can of course like add the parent layout, which is and make it a linear layout and make its orientation horizontal, but we want to minimize the number of nested layouts here. That's what constraint layout is for. So we can achieve the same thing just using base align here. So base, so we want the baseline of the reset button to be aligned with the toggle button, and we want a similar thing for the lap button here, but we want, here they are all centered, so they will be on top of each other. So we want the toggle button to be centered, but we want the reset button to be on the left. So to do that, we want to move this to the right of, so that it's to the left, and then we want the lap timer button to be on the right. So we can remove this alignment to the left, and that puts it on the right. But here you can see the buttons are really on the far left and the far right. So we want to add some padding here. So let's add some padding, say 10 dp. And that should give us a good space. So let's run this and see what it looks like. Okay, so now they are aligned. Timer still works. Chronometer works fine. Now the next thing here is we want to style the buttons this way, right? So to do that, we want to create a background button. So a background for each button here, the same background basically for all of them. So we want to use background tint and not background, because the background, if we use background, it will remove this ripple effect that Android provides. So we want to just a background tint, and we want to use a color. Let's call it button background. This won't be just a single color. We will use something called color state list, where for each state we want to give a specific color, right? So here, let's create the resource button background, not resource value. We want, we want a selector here, and we want two states. It doesn't show up here, but maybe we have the clock app. Yep, we do have it here. Sorry. So if I go back to stopwatch here and start, you could see, let me start again. You could see here, the effect is that the button has a gray background when it's pressed. So that's what we want to do here. So we want to change this to be item. So when the state is pressed here, we want to give the background to be maybe darker gray, right? So let's just say color. Sorry, this is state, pressed is true. We want the color to be Android color black, darker gray, right? And if it's like any other state, then we want the color to be maybe just black so that it can matches this Android style here. And so we can just say Android color black, right? One thing to note is the default color should be always at the bottom, right? If you do this here, then this will take over for the pressed state and it won't go to this. So it basically goes through the states in the order of definition, and that's why we leave the default one at the end, so that any state that wasn't explicitly defined here will fall back to this color. And now we can apply this. So here, actually, we don't, this is defined only from API 21, and our API doesn't need to be, to have min API level 16, sorry. So we can just make this 21. And for each button, we want to give it the same background. So that will be same background here, background here. The other thing is we want the entire style to have background black, right? So to do that, well, we can go back here, make the background be, the entire layout be black, right? And then we want the text color to be white, right, for the buttons. And so to do that, we can just go to the text color here for this. We want it to be white. Then we want the same thing for the buttons. Okay, and this should be good. So let's just this a little bit and run this and see what it looks like. So you can see here when it's in the pressed state, we did get this, right? A gray background. If we start this, the text is still working correctly and it's white, so that's good. But we still have this primary color here that is a little bit doesn't match the clock app. So let's change that. So to do that, we need to go to the styles here, and we need to customize our color primary and color primary dark. Those are the ones that are used there. So this here is color primary dark in the system status, and this is color primary. So if we want to change both, like the clock app here, we need to make both black. And so to do that, we can just say here Android color black. Do the same thing to the bottom here. And now we have it in a similar way. So that covers the this part of the chronometer. We covered a lot here. We finished the styling, wrote some unit tests for the view model, and the timer, the chronometer is working correctly. Both when we change the orientation and when it picks up like from where it left off, and when we change the orientation, the timer stays running from where it was. So here from 28, if I change the orientation, it still continues, and if I change the orientation again, it continues. So our timer is running correctly. Yep, so that's it for this video. See you on the next one.